Okay, so the first lesson that we're going to do in this unit on statistics in Math 30-3 is on stem and leaf plots and mean average. So here's today's plan. We're starting, of course, our third unit, which covers statistics. The focus for today is going to be introducing the concept of statistics. Stem and leaf plots is a way of organizing data, and we're going to introduce how to calculate the arithmetic mean average of a set of data. Anyway, let's get going. So statistics. Statistics is the branch of mathematics that deals with analyzing and interpreting numerical data. So basically, just in plain English, it's where we figure out important details about a set of numbers that we have, right? So in other words, things like average, for instance. So statistics could be used to find many things, such as the average height of a group of people, the median, or in other words, middle age of people in a country, the most common grade a class got on an exam, etc., right? So just interpreting information from numbers. Before we get talking about statistics, though, we have to talk about organizing our data because unorganized data, of course, isn't very useful to us, at least most of the time, right? So when you have to interpret a whole bunch of data, organizing that data is very important. If numbers if numbers are unorganized, like in this picture here, it makes it a lot harder to calculate any meaning from them, right? Even just looking at that picture right now, like it's just a nightmare just to see all those numbers on there. It would be way better if they were organized in some way. Now we can organize data in many ways. We can list those numbers from smallest to largest. We can group them as even numbers versus odd numbers. We can make something called a stem and leaf plot, which I'll discuss shortly, and many other ways that we can organize data. You can come up with a whole bunch of different ways, right? Anyway, stem and leaf plots. This is a bit of a unique way of organizing data, but it can be very useful in certain situations. Stem and leaf plots are where you organize numbers vertically in a table based on their stem, which is their tens value, and their leaf, which is the ones value. Now, just to be a little more clear on this one, if you had a number like 42, then the stem would be the 4, and the leaf would be the 2. Now, if you have a number that's got more than 2 digits, like let's say 123, well, then your stem is not only the tens place, but also your hundredth place. So in other words, 12 would be our stem, and 3 would be our leaf. Okay, we'll do one more. Let's say if we had 451, then 45 is our stem and 1 is our leaf. Now, stem and leaf plots are useful not only because it lists numbers in order from least to greatest, which is another way of saying ascending order, so you're growing ascending order from least to greatest, but it also shows you what tens value has the most numbers in the data set. If you take a look at this picture here, they have a whole bunch of numbers. I was going to say that they're unorganized, but they're actually listed from least to greatest, which is kind of useful in itself. But they've taken this whole chunk of numbers here, and they've put it into a stem and leaf plot. So if you look at, let's say, this first part of the stem and leaf plot, the number 15 went into the stem column of 1 and leaf column of 5. So 15 shows up right there. Likewise, 16 also shows up in the stem and leaf plot because there's the 1 and the 6. Now, usually when I make a stem and leaf plot, it's optional, it's up to you, but I just do it because I think it makes it look better, is I actually put commas between each of the numbers. I think it just helps organize the numbers a little bit better in the stem and leaf plot and less cluttered, but it's up to you entirely. This one didn't use it, and that's fine. So for some of the other numbers in here, of course, 21, it has a new stem, a stem of 2, and the leaf is 1. 23 is 2 and 3, so there's that. But notice there's another 23, so they have to list a 3 again, right? So 23 is in the stem and leaf plot twice. Same with 26. There's a 2 and a 6, and a 2 and a 6. So in other words, those show up twice as well. 30, of course, that has a new stem, 3 being the new stem, 3 and 0. 32 being the one I highlighted in this picture, they placed it as 3 and 2. And then, of course, 41 has its own little spot here with a stem of 4 and a leaf of 1. Now, sometimes stem and leaf plots are also written in descending order, which is another way of saying from greatest to least. Descending means going down, right? So you're starting at the top, the greatest number, and you're going down. This will look exactly the same, except your largest numbers are at the top instead, right? So you just kind of flip the stem and leaf plot around. Personally, I don't see a use for it, but you might encounter some questions that ask you to make a stem and leaf plot in descending order, so you just have to flip it around. Now, for an example, create a stem and leaf plot for the following unorganized list of data. I made this an absolute nightmare. I threw these numbers together. This is going to take us a little bit of time. But basically what I do is I use a tally and cross them out as I go to make sure I've hit all the numbers. Let's start by making a column for our stem. There we go. And then we'll make another column for our leaf, or leaves, I guess I should say, but we call it just a stem and leaf plot. Notice I make the leaf column a lot wider because you're going to have a lot more numbers that fill it up. Just like on that previous slide, you saw there was a bunch of numbers in the leaf column. So in other words, make sure you have that side a little bit bigger. For stems, if I analyze this whole list of numbers, notice we have a couple numbers like 3 and 9 that technically don't have a stem. When numbers don't technically have a stem, it's like there was a 0 in front of there, like you had 0, 3. So you got to put the stem as being 0. So then for our leaf, we would try writing these in ascending order. If it doesn't say so, that's just a good way of doing it. So in ascending order, the smallest number here that only has a stem of 0 would be 3. And then I put a comma, of course, to separate these, and then 9. And that whole tally comment I made just a second ago just basically means as I write them in my stem and leaf plot, I cross them off my list. So then I know that I've actually already gotten them. Now let's move up. It doesn't look like there's any more in this entire list that have a stem of 0, but there are some, like the very first number right here that has a stem of 1. So I'm going to scan through this whole list and find all the ones with a stem of 1. There's 12 and 14. I was going to say there was none others, but there was 14 there. And then I write them in ascending order. So 12 first, so put the 2, comma, and the 4 for 14, and I cross both of them out. Next up for a stem would be 2. Let's just scan this for any that have a stem of 2. There's 27 right here. There's 22 right here. That's about it. So 2 is one of our stems. And then, of course, ascending order, let's write the 22 first. So I'll put 2 here, comma, and then 7 here. And both of those are now gone. I think you're getting, hopefully, the idea of this from here. Let's just make our next stem. Let's see if there's anything with a 3 in it. Now that we're crossing them off, it becomes a little quicker to go through it. There's one with a 3. There's another one with a 3. There's 2 of them there. So 3, the smallest leaf for this would be for 33. So I'll put a 3 here and a 9 for 39, and I'll cross both of those out. Now let's scan for a 4. Doesn't look like there's a 4. No 4 as a stem here. When there's no 4 as a stem, you have an option. You can write a 4 here, or you can just not write it at all. I'm not going to write it. There's no point in wasting space, so I'm not going to write it. Now we'll scan for the next number, 5. There's 51. There's 54. That's about it. So 5. Write the leaves in ascending order. So 1 and 4. Cross them out as you go. Now let's look for 6. There's 65. We're good. So 6, 5. That was the only one. Crossing it out. Then 7. I'm going to run out of room here. I think I should have written a little smaller here, but you get the idea, hopefully. So 7. There's 72 and 72. Since those are duplicates, you can just write it 2, comma 2. Knock those out. Scan for an 8. Yeah, there's an 8. 80, it's just 84. Yeah, just 84, so I'll put a 4 there. I ran out of room on this. That's quite embarrassing, but you know what? I'm going to cheat. We're going to keep going here. Stem, leaf. I should write the whole thing. There you go. Hopefully you're getting the idea. Whatever, we're getting the idea down here. Next stem, of course, would be 9. There is 2 9s here. I'll cross out that 84. I forgot to do that a second ago. There's 91 and there's 99. So 1, 9, gone and gone. And then the last one is 105. Notice the stem on that would be 10, and the leaf would be a 5. Okay, moving on to the next one. Measures of central tendency. So we've talked about making stem leaf plots. Now we have to talk about measures of central tendencies, which is where we actually start interpreting statistics for ourselves here. A measure of central tendency is a way of finding the midpoint of an organized data set, okay? Now, generally speaking, there's 3 different ways of doing this. There's mean, median, and mode. For today, we're going to only focus on the mean. Mean is what you would usually think of when you hear the word average, okay? So, with mean, when we talk about calculating the average number in a data set, we are usually referring to something called the arithmetic mean, or also just known as the mean. The arithmetic mean is when you add up all of the numbers in the data set, so literally every number that you were given, and then divide by the total number of numbers in the set. So in other words, if you added 5 different numbers together, you would take that total sum and then divide it by 5. Now, we often represent the mean by using this symbol, an X with an arrow, or not an arrow, an X with a line on the top of it. Now, an X with a line on top of it is representing your mean, of course, and this can be written mathematically as the sum of all data numbers divided by the number of numbers in the set. Okay, much easier to see this with an example. So let's calculate the arithmetic mean of the following set of numbers and round to the nearest tenth. You're going to notice that this set of numbers is the one we were just dealing with on that stem and leaf plot question just a second ago. So all we have to do, of course, if we want to find the mean, x with the bar on the top of it, is we need to add up all of these numbers and then divide by the total number of numbers. Usually what I do is I add all these numbers in my calculator first, then I write that number down, and then I go back and I count how many numbers were in here in the first place and divide that number I got in the last step by the number I counted, okay? So first things first, let's add all of these numbers together. 12 plus 72 plus 51 plus 99 plus 3 plus 27 plus 54, yada, 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 right? I'll save you the trouble right now. You will want to put this in your calculator, of course. There's no way you're going to want to do this just using mental math. If you throw all of this in your calculator, you're going to get 852. Oops, 852. There we go. And we need to divide this by the total number of numbers. Well, total number of numbers, we can just count these. So we got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17 different numbers, right? So we need to take this total sum that we got by adding everything together and divide it by 17. Throw that in your calculator as well. You're going to get your mean, that's x with a bar on top of it, to the nearest tenth as being 50.1. So the average or mean number in that entire data set was 50.1. Next example. A class was asked to list their heights in inches in a stem and leaf plot in ascending order. Use this data set to find the arithmetic mean and round to the nearest whole number. So once again, we want to find the mean of this data set. Notice these are people's heights represented in a stem and leaf plot. Just to reinterpret this, if we look at this very first row, for instance, this means there was two people, because there are two leaves here. One person was 58 inches tall, and the other person was 59 inches tall. In this other row, we had someone who was 61 inches tall, and then we had someone who was 63 inches tall, 64 inches tall, another person who was 64 inches tall. There was two 64s right there. And then 68 inches tall and 69 inches tall. Last row here, we had two people who were 70 inches tall, someone who was 71 inches tall, 74, and then someone who was 75 inches tall. If we're finding the arithmetic mean, we have to add all of these numbers together and then divide by the total number of numbers. So x with a bar on it, that's our mean, of course, is the sum of all these numbers divided by the total number of numbers. If you add all of these numbers together, throw it in your calculator, that'll help you out here. You'll actually find that you get 866 divided by the total number of numbers. That's easy enough to count, just 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13 numbers. So 866 divided by 13. Throw it in your calculator. This gives me 66.615, blah, blah, blah. But the question does say round to the nearest whole number. Now, whole number, of course, means no decimals. So this is going to get rounded up. We're going to have x with a bar on top of it as rounding up to 67 inches. So the average or mean height of this group of people represented in this stem and leaf plot was 67 inches tall. In other words, that would be 5'7", just in case you're not aware. Anyway, so for practice, what I want you to do is in your workbook, I want you to work on these questions, page 109 to 114. Do all of the questions. I want you to work on that for today. Next class, we're going to move on to median and mode. So we'll finish that off then. If you have any questions, please send me an email or post a question on Google Classroom. Thanks.